Good evening, ladies and gentlemen. My name is Anton Boyko, and today we all gathered here to discuss how we can develop our iOS mobile applications using Azure Mobile Services. And for this evening, we will have Mr. Nikolai Soroka as a primary presenter, and he will show us all magic, and he will share us his wisdom how we can create our iOS apps with already existing Azure Mobile Services. So, Nikolai, the stage is yours.
Okay. Thank you, Anton, for such a pleasant introduction. And hi, everyone. So without further ado, let's start. I'm going to start my screen share. Okay. So first thing you do, you go to your Cloud Console, manage.windowsazure.com, and select or create your mobile service. For this demo, we're gonna select the one we already have. And on the home page of your mobile service, you see this quick start guide, which actually helps you to understand how to create mobile apps with Windows Azure Mobile Services. We choose iOS tab here, and what we see in Get Started section. We actually can create new iOS application or connect an existing one. We're gonna create new. So here are steps you need to do to actually create an application. You should have already installed Xcode and iOS SDK. Suppose you already done this. Create a table, to-do item table. Okay, we already have one, and download and run your application. So it actually offers us to choose a language. Here we have Swift and Objective-C. We're gonna use Swift. So what you do, you click download, and it takes some time to download the project. And when it's done, what you see is actually an archive which contains usual Xcode project files. So let's look inside. Okay, so inside we have a standard layout of Swift iOS application. We have framework, which is actually Windows Azure Mobile Services. Bridging header because we are using Swift. SDK is written in Objective-C, I suppose. Yes. And we have some files of source code. We have our usual app delegate, to-do table view controller, and view controller. Okay, so let's hit the run button. All right, it works, and we see empty table. Let's add new one, new item. And yes, it looks like our client application is working. Let's go back to our Cloud Console and see does it actually work or it's only a magic. We go to data. For the purpose of this demo, we are using not the default to-do item table, but to-do item 3 table because there are some leftovers from past demos. Okay, and here we see our new task. It's incomplete. Have some auxiliary columns. Here we see it. Okay, let's go back and change it to complete. All right. We go here. Complete, true. Cool. Let's take a look at the actual code that we have. All right, so yeah, okay, and here to see more. So we have our app delegate. Nothing very interesting here. Okay, here's our storyboard. And yeah, I'm gonna just zoom out. So it's actually the look and feel of our application. To-do item controller. We have this little protocol here and some views and actions, which actually calls this save item action when we are adding new item, and here the actual code. So we call in delegate did save item, and the delegate is our table view controller. So here we have all our interesting stuff. We have this table object, client object. So as you can see, the sample application has already defined your endpoint and application key. You don't have to look for it, it's right here. Here we initializing our client object, and with this client object we're treating table, the class that actually gives us all abilities we need to, all the actions we need to perform, and we do it by passing the name of the table. Here are some refresh control initializers, and in this code what we do, we actually load our list of items. So we call table, read with predicate, pass it the predicate, and here is our predicate. It has what it does, it actually filters all our items and returns only those that are incomplete. So we handling the error here, and setting the records as array of NS dictionary. So the actual data that we are retrieving is a type of NS dictionary, and in code that actually shows us the cells of the table, we set up the text as from item as it is a dictionary. Okay, so this code shows us the item, and here is a bit of code that is called when we are saving new. we create a new dictionary, pass it all our fields initialized, and call the method insert in the table, passing it our item. So it gives us back the item which is created. We appended it to records and reload data in table. Okay, looks good. So what else can we do? Let's change the selection here and reload. Suppose we want to load all items, not only the incomplete one. Okay, so to do this, let's just create new items. Fill our table. Okay, and change the predicate here to nil. Restarting our application. So now there is no filter in perform, and we need, yes, we see all our items. Okay, so let's add some accessory indicator on the table cell to actually see is it complete or not. We're gonna do this by calling it if let accessory type equals UI table view cell accessory type checkmark. Else we're gonna set accessory type equals to none. Okay, if I did everything right, we're gonna see check marks on those items that are complete. Yeah, but it's not the thing that we wanted to see. Okay, let's go back to our logic. Oh yes, of course. It should be a nested if. Gonna rewrite it. Okay. Cool. So now we see check marks on those items that are completed. Okay, what else can we do with that? Let's suppose that we have not only the text of the item, but also a difficulty of its performance. Let's add a field for that. So to do that, we're gonna switch to our storyboard. One moment, I'm just gonna re-scroll the presentation window. Okay. And we're gonna add a label. Okay, so we're gonna add a label, call it difficulty. And we are gonna add segmented control. That will have our difficulty. So it's gonna be easy, medium, and hard. Right. Okay. Let's connect with our view controller. Okay. Go back to our code again, and we're gonna edit this method to also accept not only the text but the difficulty as string. Alright, so here we have our variable, and we're gonna switch on our segmented control, select segmented index. So if it's 2, we're gonna say the difficulty equals to hard. If it's 0, it's easier, and in all other cases it's gonna be medium. Alright, so here we're gonna add difficulty. Yeah, that's the syntax check. Let's rename variable to not to mess up. Just call it diff. Okay, and here we're gonna pass our diff. So now we have this protocol that we are passing our difficulty. Go back to our table view controller. And here we have our delegate. Yeah. Yeah, string. Of course, it's a string. So we're just gonna add this key value pair to our dictionary. Gonna say it's difficulty, and it's our element here. Okay, let's run it. If I did everything right, we're gonna see new control in our add item view. All right, here we have it. Let's say it's new finish the demo. It's a very hard task, and let's save it. All right, we see it in our table. Let's go back to our Cloud Console and browse our data. Cool, so what we see here is actually we have this new column, and as you can see, it was created without any additional handling in our web browser and our console. You can add or remove your columns, change your model, the schema of your tables, just by changing your client code. To do that, when you're creating your table, you have to check the dynamic schema checkbox. Alright, looks nice. So we need also to see our difficulty in our client application. Let's add the code that does it. So we go back to this part that actually shows us our cell view. So what we're gonna do is we're gonna get the item difficulty as string, and all this construction, all this if will be executed when diff is not nil. So when we actually have this element in our dictionary. So what we're gonna do, we're gonna set cell text label text, and our parentheses. All right. Okay. Let's just extract an extra variable. So what I'm doing is I'm extracting the part that actually grabs the name of the item, and then if we have a difficulty in our item, we're gonna add the difficulty in parentheses to the name of our table cell. Okay, let's hit the run button. Cool, so we have all this item, nothing crashes, and we have this finish the demo item that actually has its difficulty level. Let's add new one. Okay, no, I'm just gonna have a lot of fantasy, just gonna create a new easy medium task. Yeah, looks good. All right. What else can we do? Let's go back to our Cloud Console. And as you can see, you also have, when you go to table view, you can browse your data. You can see some scripts here that are executed when you perform the operations like insert, update, or delete, or when you read the items. By default, it looks like that, so it doesn't do any additional logic. But if you have one that is supposed to be on your server side, you can add this in these points. Also, we have our columns and permissions. So here's a very interesting part. For insert, update, delete, and read permissions, we can specify who can actually, or what can actually do all this operation. So here it can do everyone, anybody with the application key. Our client application have had this key here. And also it can be authenticated users. So let's change this part here for authenticated users. In most of the cases, you're gonna need to authenticate your users. You're gonna need to authorize them and prevent from like inserting into the places they don't need to insert data or read from. So we're gonna change, we're gonna hide our insert operation into our table behind the authenticated user's permission. Let's go back and try to create some item here. Unauthorized access. Unauthorized access. And if we go back to our Xcode, so I'm just gonna rescroll it here. Yeah, so as you can see, we log all our errors here, and it returns our 401 unauthorized status. So how can you change that? We have very easy way to do that, because our client object has the magic login with provider method. Let's see how it works. Okay, so here we have our login as provider. It receives our provider. It can be a string identifier for authentication providers like Twitter or Google or Facebook. Let's gonna use Twitter. Okay, controller, we're gonna put self animated true completion, our completion block. One moment here. Error. And go back to the code. I'm just gonna copy the error handling code for the purposes of the demo. Okay, here. Otherwise, we're gonna print line user is authorized. All right. Restarting our application. And voila, we have this standard OpenAuth, I guess, login screen on the Twitter. And it receives our, it wants us to input our name or email. Gonna click cancel here. And what we see, here we see our error. The login operation was cancelled. So what you can do, you can actually catch all these cases when user didn't log in and do the logic if you want on the client. All right, let's go back. So now I'm gonna go back to our client console, switch back to scripts, and what I'm gonna do, I'm gonna ask Anton for a little help with JavaScript magic. What we need actually to add additional column here that will identify was it authorized user or not. Anton?
Okay, so for achieving this task, we can try to write some simple script. So let's type item dot, for example, created by. Yeah, something like this. Equals to user dot user ID. Yeah, but the letter D should be lowercase.
Yeah. Okay, something like that, yes.
So, yeah, so it's just semicolon at the end.
Oh yeah, sure. Okay, let's restart our application. So now we see our Twitter login page. Here it's loading. Okay, I'm gonna input my login, and I'm gonna put away the simulator to input my pass. All right. Click sign in, and yes, user is authorized. Cool. So now we try to add a new item and see what happens. Okay, let's go back to our console. And here we see that there's our Twitter ID, and all other records have null in this column. So in this way you can get the ID of the user that has created this item and do the logic you need to do on the cloud side without performing it on the client side on the mobile application. Okay, and I guess the last thing that we're gonna do is to see our custom APIs. So you go back to your mobile service tab, click API tab, and here we have my news API. It has get, post, put, patch, and delete methods. So here you can write some code. Okay, again a JavaScript magic. For the purpose of the demo, we're gonna use this post function and change the table name to table 3. So what it do, it actually just returns us all the records that we have in the table. We have this getting this table pointer and performing very like much operations that we do on the client, passing it the filters, in this case the empty JavaScript object, and the callback function that says that the status is okay and send the results back to our client. Very simple, very straightforward. Go back to our code. So how can we do that? We go to our onRefresh method that did the data loading. And we're gonna use our client here that we created here. Let's make it a class field. All right. Yeah. One moment. All these optionals that you have in Swift makes you write a lot of exclamation and question marks. So we need to set all the exclamation marks to unwrap the optionals. And we have our client. So our client object has this very cool invoke API method. So it receives the name of our API, let's check. Go back and check the name. The API name is my news. My news. Body we can pass nil. HTTP method, I guess post. Yeah, we go. We are right post. Empty parameters and empty headers, and our callback block. Here it's a closure. Just one moment for you to see all the code. Okay, it needs new. Alright, so at this point I'm just gonna cheat a little bit, and what I'm gonna do, I'm just gonna copy the code that handling our table here. Our handling in the code is reading from our table. Alright, here. And so as it is a framework, the result we are retrieving is actually already parsed data. So it's not a raw JSON NS data object, and we can do a straightforward way and just assign it to our records. Alright, a little bit of copy paste. Okay, seems good. Comment out here. And run it again. Okay, it asks me to sign in, but I'm gonna just cancel that. Alright. Looks good, but something's not right because we are retrieving data from other table, I guess. So saving our script again, reload. Yeah. Okay, so we have all our items here. We're gonna mark it as complete. And looks good. So what we did, instead of working with the table object that has all these CRUD operation methods to work with, we invoked our custom API that actually is very simple and returns us the same data as we can read from the table. But if you have some other logic that goes beyond the CRUD operations over a table, you can do this very easily by invoking your APIs. You can also pass some data for body, when you need to upload something or pass some params or external headers. And it's all in one object. You don't need to set up any networking framework or other things.